assistant professor in electrical engineering courses, right? English or Tamil?
English, sir.
Sir, little bit louder, sir.
Yeah, sure. First, I will start with an basic, right? So, as your principals are instructed to give the basic information on electrical engineering. So, that's more important because the first and foremost thing is in our college. I don't want to hide anything. In our college, 2 students have died because of electric shock. Do you know that? Not in any other college, in our college, not in college, but in home. In their home, while operating the iron box, 1 student have died. So it's may the soul rest in peace. But that's a sad news. Second student is a second year student. He worked in an industry. So while working in an industry, he touched the 3-phase circuit. These are all single-phase circuit. He touched the 3-phase circuit and he died. Right? Why I am saying this means you want to be careful whenever you are dealing with an electricity. Right? Even in your home, you want to know what is the safety procedure whenever you are operating on the electrical devices and electrical equipments. First thing is, I will start with an voltage circuit. What is voltage? What is known as voltage? Power. Then, okay, I will start with an positive potential and negative potential. What will happen whenever you are having a positive potential nearer to the negative potential? You are having a positive potential here. You consider that. So this is what positive potential, right? In battery, this is what positive potential. This is what? Negative potential. You know that? Yes. Very good. What will happen to the positive potential and negative potential? Whether it will attract or repel? Attract. What will happen if there is a positive potential and positive potential?
It will repel.
What will happen if there is a negative potential and negative potential?
Repel.
What will happen if there is a positive potential and negative potential?
Attract.
Negative potential and positive potential?
Attract.
Okay. Now, this is what? Conductor. Okay. So this is positive potential, this is negative potential. So what I am doing is I am connecting a conductor between the positive potential and negative potential. Okay. Now I am connecting the conductor. In that conductor, what will be there means atom. In this particular conductor also, there will be more number of atoms. In this conductor also, there will be more number of atoms. In atoms, there are, what are the particles? Proton. Very good. Protons, neutrons and electrons. We will not consider the protons and neutrons until we are going to make any bomb, right? Atomic bomb. You know that, right? Atomic bomb create pandradha. So we need to concentrate on the protons and neutrons. We are not going to create a bomb, right? We are going to create an electrical circuit. So we will concentrate only on the electron. Nothing but electron. Electrons are big charge. Very good. Negative charge. So here also there will be more number of electrons. Atoms, actually subatomic particles, there is more number of electrons. I am not concentrating on the protons and neutrons here. I will concentrate only on the electrons here. I will concentrate only on the electrons here. Electrons are negative charge. So this is positive charge, this is negative charge. In this conductors, electrons are there which are negative charge. So this negative charge will repel the electrons, because electrons are negative charge, right? This negative charge and this electrons which are also negative charge, which will repel. So this positive charge and the electrons in this conductor will attract. Very good. So now what will happen to the electrons? The electrons will move from negative potential to positive potential. Very good. So if anyone is asking what does the current means, flow of electrons, you should not say that. Flow of charges. So actually what will happen means, flow of electrons will happen. Flow of electrons will be always not from positive potential to negative potential. Flow of electrons will be always from negative potential to positive potential. Don't forget this. Current only will flow from positive potential to negative potential. Electrons will always flow from negative potential to positive potential. Don't forget this. Because electrons are negative charge, so this is negative potential. Negative charge and negative potential will repel. So here it will be flow from negative potential, and then positive potential and negative charge of the electron will attract, so it will goes to the positive potential. Understand? Electrons will flow from current will flow from now you understand what is now what is mean by voltage means. This is what potential? Positive. This is what potential? Negative. What is mean by voltage means? Potential difference between 2 points. This is one point, this is one point, right? Potential difference. There is positive potential, there is negative potential, so there is a potential difference. So this is what positive potential, this is negative potential, right? So there is a potential difference. Potential difference between 2 points is known as voltage. The flow of electrons will be always from negative potential to positive potential. Flow of current will be always from positive potential to negative potential. You know now what is known as voltage and current, right?
Yes, sir.
Understand? Any doubts? Okay. Now we can go for this particular thing. Actually, this is DC. This is known as DC source. Here, this is an here நான் கனெக்ட் பண்றேன். நமக்கு வீட்ல வரதுலாம் whatever what is a source it is, whether it is a DC or AC. AC. வீட்ல இருக்கிறது in our home whatever we are using is an AC current. Here in battery it is an DC current. You consider that I don't want to deviate from this, so you can consider that this is positive potential, one is negative potential. Okay, you don't want to consider this third point. I will tell you. I will come to the later. What is that third point? The large hole is there, right? So I don't want to come to that point now. So I consider that this is positive potential and this is negative potential. So one is connected and this is actually it is in parallel.
Yes, sir.
One is connected in parallel, one is connected in series. What is known as series? I will draw it a diagram. Paper and paper. You can consider that this is what one bulb. Okay, you can consider this is bulb. This is a symbol of the bulb which we will draw in our engineering study. So that this is a symbol of the bulb. So what I have done is I have connected this is what source. These 2 points, right? So one is connected to this point, another is connected to this point. You consider that this is lamp 1 and this is lamp 2. Okay. So whenever I am turning on this thing, so what is happening actually? You can be able to identify any difference here. So you can see the both lamp, so that you can understand what is the difference between. This is actually series. This is lamp 1, and you consider this is lamp 2. I have connected in parallel. You can see the difference practically, and you can. What is happening here? This is parallel circuit. This is series circuit. Can you able to identify any difference here? Darkness. Intensity of the light, not darkness. Intensity of the light is higher in this parallel circuit. Am I right?
Yes, sir.
Intensity of the light is lesser in this circuit. Am I right?
Yes, sir.
Clear?
Yes.
Can anyone tell why this is happening? It's a more complicated question. I don't want to go into that. Can I get the script? What is this? What is this? So what I am doing is, this is one biscuit, right? This is one whole biscuit. What is your name, ma?
Gokul Raghav.
Huh?
Gokul Raghav.
Gokul Raghav, right? One full biscuit is given to the Gokul Raghav. Okay? What I am doing in the second biscuit and what I am doing is, I am breaking into the 2 pieces, half, right? This is half and this is half. I am breaking into the 2 pieces and I am giving that to the 2 students. What is your name? Naveen. Naveen and Raghunath, I have broken the pieces and I have given that, right? So who will eat more?
Go.
Vocal will eat more, right? Is there any doubt in that? No. This is what parallel circuit is doing. The voltage is giving a voltage. Actually, what it is doing is, so two biscuits I am giving. 2 biscuits I am giving equally to the 2 students. So his stomach is filled. He will give more intensity, right? I am giving the voltage parallel. I am not blocking down anything. So I am giving that to the parallelly. 2 biscuits, 2 students, parallel I have given. So his stomach is full, his intensity, his energy is higher. So in the series what I am doing is, I am blocking that. What I am blocking is voltage. Here I am not giving the voltage full. Instead, I am blocking the voltage. Half of the voltage I have given to this particular bulb. Half of the voltage I have given to the next bulb. So intensity is very less. So now the question is, what will happen to the voltage in parallel? What will happen to the voltage in series? Voltage will be full. In simple words, don't complicate anything. I don't want to go into the technical words and all. Voltage will be given fully in the parallel circuit like this. I have given 2 equal biscuits, right? 1 biscuit to this, 1 biscuit to this person. So equally I have given. So energy is more. Here, I have not given the voltage fully. Instead, I have broken the voltage. Half of the voltage I have given to this particular student. Half of the voltage I have given to this particular student. So automatically what will happen? His energy is not full, his stomach is not full, his energy is not full. So the intensity will be less. Can you able to understand what is a parallel circuit and a series circuit? In parallel circuit, voltage will be high or full. Full voltage will be applied to both the bulbs. Here, half of the voltage will be applied to each bulb. If you are connecting third bulb, then it will be divided to 1 by 3. If you are connecting 4 bulbs, 1 by 4. If you are connecting 5 bulbs, 1 by 5. That's it. Here also 1. Here also 1. One full biscuit, another one parallel circuit, 1 full biscuit. Intensity will be always full, or intensity of the light will be high. Okay? Can you able to understand? Yes. Can you able to understand what is the difference between parallel circuit and series circuit?
Yes.
Any doubts? Okay. So in parallel circuit, what will happen means, I am giving that voltage fully, right? So what I am doing is, even if this particular take these biscuits. My HOD sir is Dr. M. Armu. So he yes, listen. In parallel circuit, the voltage applied is full, right? I have not divided any voltage here, right? So equally I have given the voltage. So what will happen means, if I am removing this particular bulb here, right? This bulb is still turning on, right? It's not affected. If you are removing one bulb, it's not affected in parallel. So what is happening in series? You see this. If I am removing this particular bulb here, what is happening? So second bulb is affecting the first bulb, right? If I am removing the second bulb, the first bulb is automatically turning off. So it should be connected in series, which means if any broken wire is there, there is a broken wire means this will also be affected. Okay, here if there is any broken wire, this will not be affected. Right? This is like a bypass road. Always we can go right in parallel circuit. That's why in our home we will always use parallel circuits. In our home, what is the circuit we will use? We will not use series circuits. Why series circuits are not used? Voltage will not be given fully. Very simple words. Understand is more important. You don't want to know the technical terms. What is known as technical terms? Voltage is not given fully. The intensity will not get higher. So what will happen? We will get less output. Whereas in parallel, we will get high output. Moreover that, even if one bulb is repaired, or if one bulb is removed, another bulb will be always there for your support. Here, if one bulb is removed, then automatically another bulb will be
Turn off.
turned off. Very good. So we should always use what type of circuit in our home? So in our home one bulb is there in our one room. The second room you want to connect another one bulb. Which connection you will prefer? Parallel circuit, right? Then where the series circuits will be used means in decorations, right? You can see that serial bulbs are there, right?
Yes, yes.
So in that only serial bulbs. One bulb, if you are removing that, and one bulb there is an broken, you go and see that. If one bulb is broken, right, or if one bulb there is an a damage is there, the entire series bulb will be damaged. Then what will happen means that bulb has to be broken down, and then you want to connect the wire. You want to do the rework for that. Okay, in parallel it is not happening. One bulb is broken or damaged, nothing happens. Other bulbs are always turned on. Can you able to understand?
Yes, sir.
Any doubts? No, sir. Can you able to recall everything? What does mean by voltage? What is mean by voltage? Potential difference between 2 points. Potential difference between
2 points.
positive potential and
Negative potential.
potential difference between 2 points is known as
Voltage.
What is known as current? Okay. When in which direction the electrons will flow?
Negative.
Negative potential to
Positive potential.
electrons will always flow from negative potential to positive potential, because negative potential will repel the negative charge of which is known as electron, and positive potential will attract the negative charge which is an electron. What is known as current? The electron will flow from just not current. Current means current will always flow from positive potential to negative potential. So in series circuit what is happening, in parallel circuit what is happening? In parallel circuit, voltage is fully given. Each and every bulb the voltage is fully given. Here the voltage is given half. If it is 2 half, if it is 3, 1 divided by 3. If it is 4,
1 by
1 by 4. One quarter voltage will be applied. If there are 4 bulbs or that, quarter voltage will be given to the one bulb. Can you able to understand?
Yes.
Any doubts?
No, sir.
Clear?
Yes, sir.
So in parallel circuit, even if you are removing the one bulb, another bulb will be glow. So if one bulb is removed in the series circuit, another bulb will not glow or will turn off. Understand?
Yes, yes, sir.
So always you should use parallel circuit in our home, not series. Any other doubts?
No, sir.
Next we can go for the next experiment. Any other next experiments? This is what? This is actually motor model, right? You know what is the electrical equipment which is there? Sir, any other important points? This is my HOD sir, Dr. M. Aramu Babu. He is having more than 10 years of experience and 12 years of experience in electrical engineering itself. Right? He is having so much of experience. He will tell some important points on series circuits and parallel circuits.
Okay. In about the net resistance, we will talk about this. If you are, what is resistance? Okay, resistance means it is limiting. Yeah, limiting. If you are connecting a resistor in resistor, what will happen? It will limit the current. That means it is giving a opposition. So you will get just like a tap. If you are closing the tap, what will happen? Close பண்றீங்கன்னா என்ன ஆகுது? Water ஓட flow வந்து கம்மியாகும். Just like that in a water pipe we are using it. Here one use பண்ணிக்கிறோம். We are using a resistor. So what will happen? The resistance will oppose the flow of current. Every material will have a resistive property, so it will have a resistance. So for a flow of current, definitely we should have a resistance. Resistance இல்லாம என்ன பண்ண முடியாது? We can't make the current to flow in an element. Correct? So comparing to series and parallel circuit, if we are taking a series circuit, the net resistance will always increase. Okay, the net resistance will always increase. What do you mean by net resistance? Net resistance. What is net resistance? I am taking these 2 bonds. What is the weight bar?
Another way there is more number of speed breakers are there. You are going in a car. One way it is pure road, NH47. Another road it is having bumps or speed breakers. More number of speed breakers. Okay. Which road you will prefer? Whether NH47 road or more number of speed breakers? NH47 road. Similar to that, the current is also. Current will always choose the path which is having a plain path, right? Which should not have any speed breakers. What is the speed breaker for the current is resistance. If there is high number of resistance for the current, it will not choose that path. If there is no resistance, the current will choose that path. Similar to our driving circuit, right? In our drive, if we are driving, what will happen? You will choose only the path which is having less number of speed breakers, and you will not choose the path which is having high number of speed breakers. Similar to that, current will choose only with less number of resistance, and current will not choose the path with high number of resistance. Understand? So this is actually a motor model. Actually, one particular thing is not missing. Actually, we need a neodymium magnet. This magnet is a normal magnet, and we have not get the neodymium magnet because yesterday only we got the information. So sooner or later, I will. Can you able to show the? Can you able to see the vibrations here? Some vibrations are there. I cannot able to rotate that. It will be clearly rotating, but this is rotating, right? Can you able to see that?
Yes.
Why it is not having continuous rotation means because of the magnet power. Magnet power is less here, so we need a neodymium magnet. At least you can see the vibrations, right? Light vibrations are there. So yeah. This is what the rotation. Can you able to see without giving any input, it's rotating. If you are having a neodymium magnet, it will have a fantastic rotation. You can see that. But unfortunately, we cannot get a neodymium magnet yesterday. Can you able to see what is happening here?
Yes.
Yes. This is what motor action is. So in our home, where are the motors? You are seeing in our home. You see that in your home you can have a fan, right?
Yes.
Inside the fan, what is there? Motor. Other applications? Inside the mixie, what is there? Motor. Inside the grinder, what is that? Inside the washing machine, what is that? Inside the electric vehicle, you know what is known as electric vehicle. Now we are having not having electric vehicles in so much area, but what is there in electric vehicle? Electric vehicles inside that, what is that? Batteries. Batteries and motors, right? So it's water rotation only. In the fan, mixies, grinders, then washing machines, electric cars, everywhere there is a motors. So now what type of motor we are using is AC motors, but sooner after, within how many of them know super fan? Super fan, yes. Actually, now it's Coimbatore is having the main area for creating the super fan. Near Tudilur, there is a company known as not Tudilur. It's away from Tudilur. The name of the company is known as Versa Drives. Versa Drives company is creating super fan. You can purchase a super fan. The important advantage of super fan is the efficiency is more than 80 to 90%. The losses will be very less. Which means, in a simple words, with a normal fan, if you are paying only, consider that you are having only one fan and you are getting an electricity bill of rupees 100 rupees. Okay? If you are replacing the normal fan with the super fan, right? Then you will get an electricity bill not even 50 rupees. It means less than 50 rupees. If with the normal fan, how much rupees you want to pay? 100 rupees means if you are replacing the normal fan with BLDC fan, which is not a super fan, BLDC, brushless DC motor fan, not AC motor, brushless DC motor fan, which is known as super fan. If you are going to the internet, check it for super fan. There are no more number of fans are there. So the cost of the fan will be somewhat high, but the electricity bill will not be 100 rupees, will not be 80 rupees, will not be 70 rupees, even it will not be 50 rupees, it will be less than 50 rupees. Which means cost reduction will be more than 50%. More than 50% you can reduce the cost. So if you are somewhat above the level, if you can purchase, please go for BLDC super fan. And the second thing I want to remember you is, if you can, you should never use this particular type of, what type of lamp it is? Serious lamp.
This is called as incandescent lamp. Okay. It is incandescent.
This is incandescent lamp. You should never ever use this incandescent lamp in your life. If there is incandescent lamp in your home, please remove that, throw it away. I am doing this only for experiments, right? For lab setup, we can use this this particular type of lamp, which is known as incandescent lamp. You should always use either, preferably LED, or in the worst case scenario, you should use CFL. Okay? Preferably LED only. I will, as an electrical engineer, I will say that if you have any bulb like this in your home, today evening you want to remove that, throw it away in the dustbin, you want to purchase LED lamp, or at least CFL lamp. Okay? Don't go for CFL lamp. The date of CFL lamp and LED lamp are similar. Okay, somewhat same. Go for LED lamp. LED is light emitting diode, right? That's more technical terms. So anyway, light emitting diode, LEDs. So now we can go for this particular. How it is rotating? Through magnets. Very good. Through magnets only it is rotating. What will happen, for example, it's known as, I will always say this as an, it's not in general, but I will always say that as an biscuit and dog. Okay, can you see this? This is a north pole. Okay, to consider this is a south pole. This is north pole, this is south pole, right? What will happen to the south pole now? North pole and south pole, what will happen? Attract. So here there is a north pole. You consider this is 0 degree. You consider this is particular, whatever it may be. You consider this is 90 degree. You consider this is 90 degree. With respect to this is 45 degree. What will happen to the south pole? Whether it will move in the anti-clockwise direction or clockwise direction? Why? North pole will attract, so it will move for clockwise direction. Clockwise direction for an angle of 45 degree. I don't want to go into detail to this thing. So anyway, so south pole will attract north pole, right? So what will happen now? Now there is a rotation. Am I right? There is a rotation. So what will happen now? If there is north pole, if there is south pole, what is happen now? Whether there will be any movement here? No, because already it is attracted, right? Here it is not attracted, so south pole will move towards north pole. Here already it is attracted, so there will not be any rotation. Am I right? Here there is no attraction. There is no south pole is not attracted towards north pole, so there will be a rotation. Here, after attraction, no movement. So motor should always rotate, right? So what I will do is very simple trick. What I will do is I will move this particular north pole. Here this is a south pole. I will move this particular north pole to this particular position. First here, right? Now it is going. It is attracted here. After attraction, it will not rotate. What I will do? I will move.
of what is the conversion taking place in a motor? There is energy conversion.
What is motor? Can anyone tell me? No one. Electrical energy to mechanical energy. What we are getting here? Rotation, which is nothing but mechanical energy. So what I am giving here? Battery, right? Battery only I am giving the supply and then only it is rotating, right? I am giving the supply, which is nothing but electrical energy. I am getting the rotation, so which is nothing but mechanical energy. So motor is doing electrical energy to mechanical energy. What is motor? Which is converting electrical energy to mechanical energy. What is law of conservation of energy? Energy can neither be created nor be destroyed. Right? We cannot create any energy. I cannot create energy. If I am creating some energy, means I am a Shaktiman. Do you know Shaktiman? I am a 90s.
Yes.
Yes, very good. If I am creating some energy, means, right? I am a Shaktiman. So I cannot create energy. What I am doing is I am having one energy, which is known as electrical energy. So another energy is I want this mechanical energy. So I am converting this electrical energy to mechanical energy. So motor is converting the electrical energy to mechanical energy. What is generator? Reverse of this. Reverse of this means? Very good, very good. This person is brilliant.
These two should be done in the presence of magnetic field. Okay, now further only we are using magnet here. Okay, if you want to in a generator and as well as in the motor, you need magnetic field. Then only this conversion will take place. Okay. Hold it on.
Yes.
Which standard you want?
All are 8 standard.
Any doubts?
No, sir.
Nothing. All are clear.
Yes, yes.
Well understood.
In the next class we are coming, you have to prepare a model. Okay, so we will share what is the procedure and what are the things you need to other latest Not பண்ணிக்கணும். Only papers. Take it.
What I will do is,
Sir, why sir we do not use this bulb, sir?
why? Very good question. Why? Very simple answer is, for 10 minutes I am turning on this bulb, right? This is, I think this is parallel, right? Okay, anyway, I don't want to go turn on this thing. So after 10 minutes, okay, if I am telling you to remove this bulb with your bare hand, what will happen? Shock is I want to remove this bulb only, not just heat. So much heat. That's why I have taken the kerchief, right? Most of the energy I am giving as an electrical energy. Here, what is happening? Electrical energy is converting to here electrical energy is converted to mechanical energy. Here electrical energy is converted to light energy. Very good, light energy, right? So this light energy means I want to convert all the electrical energy to only light energy, but unwantedly, right? This Gund bulb or incandescent bulb, what it is doing is a nonsense. What it is doing is it's not converting all the energy to light energy. Instead, it is converting the electrical energy to heat energy, which I don't need. Who needs the heat energy? Do you need the heat energy? Whether you need heat energy or light energy. Then all the electrical energy has to convert it to light energy or heat energy. Light energy. All the electrical energy has to convert it to light energy and not heat energy. But this bad fellow, what it is doing is, he is doing a nonsense to me. He is doing 70% of electrical energy is converting that to light energy. It's okay for me. But other 30% it is converting that to the heat energy. Which I don't need. Which is harmful to the environment. It is heating the environment also. It is heating and the heating the environment. Unnecessarily it is creating heat energy. So its LED will not create. It's because if I am having an LED, I can remove the LED with the bare hands because it will not create heat. Very good question. Very good question. Any other doubts?
Only that, one more thing, you are paying for that. Electricity
paying
is
for
not free of cost. Also, you, for creating electricity, you are spending coal and all. Yeah. What is indirectly, that is polluting the environment. Okay. If you are unwantedly, if you are using a lamp or a fan, what will happen? Indirectly, you are polluting the environment. So that we have to reduce that.
Global warming. You know what is known as global warming, right? Unnecessary heat is creating by this bulb, like this. There are 100 bulbs, what will happen? Unnecessary heat will be generated in the environment, which is creating a global warming again. Heat is nothing but, right? Heat is, we don't need heat, right?
Any other questions, ma'am?